Alright, I just want to go through a couple things real quick with you so that you're prepped for this lab that we're going to work on Thursday and Friday. Also, don't forget to submit your VSEPR worksheet number 1, front and back. You should have your Lewis dot structures, ABE formula and name, your molecular geometry name, and the VSEPR drawing for each compound on that sheet, front and back, should be turned in tomorrow, Friday, 1/29. What I want to talk to you about today real quick is, first and foremost, we have the keys, homework keys for self-check. I put the Lewis dot structures for compounds page up there that shows the Lewis dot structures, the ABE formula and name, and the drawings done correctly. Check your work there. The other thing I did is on the Lewis dot structures, any lone pair that is red does not contribute to the ABE formula, but those that are blue, they do contribute. So that's just a way for me to show you where the E values are coming from. We have 2 lone pairs and 2 bonded atoms, so that's how we get the AB2E2, which gives us the bent shape. You look down here, none of these red electrons contribute to the E in our molecular geometry. Only the pair on the top of the nitrogen that's blue gives you the E. Those are right here, and that's what forces the bonds down into bend. I went through and did the rest of these for you. So if you have any questions on those, please make sure that you send those to me on an email so I can address them in tomorrow's video. 2 things I need you to understand as we go into the lab. One is something called electron domains. Electron domains are items that take up space around the central atom in your molecular geometry, in your Lewis dot structures. So when we look at our Lewis dot structures, we can see that this one has 1 element. It has 1 electron domain. This one has 2 elements, or 2 electron domains. If you have 1 or 2 electron domains, you're going to have a linear family. That's going to be what we call the electron geometry. The electron geometry, if you have AB or AB2, is linear. If you have 1, 2, 3 atoms around your central atom, that gives you the triangular planar shape. It also gives you the triangular planar family, or the electron geometry would be triangular planar. 1, 2, 3 items around it. If we go to tetrahedral, now we have 1, 2, 3, 4 atoms, or 4 items or domains around the central atom. That puts us in what we call the tetrahedral family. Another member of the tetrahedral family also has 4 domains. The domains are a little different though, because we have a lone pair of electrons, that's 1 electron domain, and then we have 3 atoms, that gives us a total of 4 electron domains. If you have 4 electron domains, you're in the tetrahedral family. Another one that's in the triangular planar family is AB2E. AB2E, that's your bent, but it has 1, 2, 3 electron domains, which puts it in the triangular planar family. The last one is your AB2E2, which is bent. It has 1, 2, 3, 4 domains around it that puts it into the tetrahedral family. Now, molecular geometry are the shapes we went over yesterday: linear, triangular planar, tetrahedral, triangular pyramidal, bent, and bent. If they're asking for the electron geometry, they want to know what family is it in. Is it linear, triangular planar, which would be triangular planar and bent with 1 pair, or is it tetrahedral with the tetrahedral, triangular pyramidal, or bent AB2E2? All right. Last thing that I want to go through with you, which actually relates to the lab itself, is when you get through part 1, make sure you follow the directions and click all the boxes. When you click on here, click model, click all of your check boxes. When you go to build your model, I want you to stay limited to 8 electrons total. 8 electrons total around the center atom. So that could be 4 bonds, it could be 3 bonds in a pair, It could be 2 bonds and 2 pairs. It could be 3 pairs and 1 bond. You could have 2 doubles. You could have a single and a triple. You could have 4 singles. So stay within the octet. And then also make sure you don't have any more than 4 domains. You can have 1, 2, 3, or 4 domains around the central atom. Don't go above that. On the lab sheet, which you can print off, you're going to draw your VSEPR drawings in these, and then write down the molecular geometry, which is the shape, your electron geometry, which is the family. That'll either be triangular planar, tetrahedral, or linear. And then write down the bond angles. And those bond angles should show up on the actual simulation. So if we look at the simulation here for a second, just click on this play button. It'll open up for you. And when it opens on part 1, which is Thursday's assignment, we want to click on Model. Down here we want to click the molecular geometry, electron geometry, and show the bond angles. If you want to start from scratch, just hit these little red X boxes. That takes you back to your base. You can put in a bond. You can put in a lone pair. You can put in a second lone pair. You can put in a second bond. And then you can actually just point to this, and you can move it around so that you can get a view of how to draw it. Okay? So if we took away these and made a tetrahedral, you could grab that ball and put it here, and then you could start to spin this around a little bit so that you could get a clear view of how all of this is set up and how to draw it. For this one, be regular bond, here's your wedge, and there's your dashed line. Have part 1 done, which is the table and the questions. The table and the questions, they're at the top of page 2. Have that done for the start of class on Friday. And when you're looking at these as well, you want to stay within the octet, and you want to stay within the up to 4 electron domains whenever you're answering these questions. When we get into part 2 tomorrow, we'll go into the other end of the simulation, which is if we go to the real molecules, and you can see they're already shown for you. You can click all of the same choices, and now you have your water molecule already done. You have your sulfur dioxide, which is already done. You have some of those odd ones, like this is called a seesaw, okay? And this is a molecule with 5 electron domains, which is not typical. So that's where you'll be working tomorrow as we get into part 2 of the lab. This will be due on Monday, February 1st. We'll finish it up. We'll do it in class Thursday, Friday. You'll have the weekend to wrap up anything you need, and then we will submit this. For those of you that are remote, you'll just submit it electronically as a document on Tuesday or Monday. If it's due Monday, it'll be open until Tuesday. Again, please email me if you have any questions on anything so that I can help you out. All the resources are available for you in the Unit 7 module. Don't forget to check your homework. Don't forget to turn in the VSEPR worksheet number 1. Scan or take a picture and attach that. Submit that by the end of the day on Friday, and your lab by the end of the day on Monday. Hopefully some of you guys will be back. Ladies will be back on Monday. If not, continue to do little video updates. As always, email me your questions so I can address them in the next video.